Good evening to all of you. I am Suresh. I am going to take a lecture on application of geophysical method for various application of geology, where I will give you a lecture on GPR, then electrical resistivity method, then seismology, and I will show you some integration of geophysical method with remote sensing. So coming to the first slide here, I'm going to explain you what is geophysical method. So geophysics, it's used the principle and practices of physics for solving the geology. How it is doing? What is geology? Geology is the data collection in mainly two dimensions. Means we are doing we are doing survey on ground only. But what is geophysics? It's at the third dimension, means subsurface. So it means it uses the two dimension as well as three dimension means subsurface to know the structure beneath the earth. Where there is two types of geophysical survey: surface geophysics and web logging. Surface geophysics is we are doing observation are made at the surface in XY directions, and the interpretation is done in Z direction. Where web logging, we are first making the borehole in above the mentioned properties, and then investigation are in the Z direction and interpretation in the X and Y plane. Then what is exploration method are divided into two parts: active method and passive method. Active method used by controlled source, and passive method used by natural source, where natural source are sun. We are taking this energy from the sun, and in active method we are using various equipment to generate the source. Means also we are using some dynamites, explosives, hydrophone, air gun, all that we are using to generate the active source. Geophysical problems are generally inverse problem. Why? Because we are doing measurement on the surface and we are looking inside the earth. So first first model is made, then on the basis of field measurement we compare the calculated value on the properties of the model. The model is then changed by successive iteration till time that the observed value match with the calculated value. Now come to the how much method there is. There is mainly 5 types of geophysical method: gravity method, magnetic method, seismic method, electrical and radiative method. I am going to deal these 4 methods. Where gravity method do what measure? It measure it check the density contrast, and magnetic method is measure the magnetic susceptibility, and seismic method do elasticity, means elastic wave velocity, and what electrical method do? It measure the resistivity, conductivity, electrochemical potential and inductive properties, means electromagnetic method. Where all the methods work differently for different types of material. Means when we are having some objective, it is not that we can use any type of method. First we have to check which is suitable method. On that basis we can go to the particular method, then we do the survey, and then we do the processing, then interpretation. So now I'm going to explain you what is how we can utilize seismology to know how earthquake occur, what is magnitude, what is fault, okay, and what is epicentral distance, how we measure all these parameters to calculate the earthquake, and the focus, where is the focus of the earthquake. To know all this we use seismology. So how earthquake occur? There is one theory, elastic rebound theory. Elastic rebound theory which suggests that earlier the bed is like that, but during the pressure, when the pressure is taking place from both sides, so it is start crumbling. So you can see this getting trough, getting trough, and then after another force, shearing force, taking from two sides, other sides. So this get seared, and now after when the force is in extreme, then what happen? Then the displacement will take place. So during this displacement, whatever the energy formed during this force will release in the form of P as Rayleigh wave, love wave in that form, and earthquake occur. So here is the example. Here you can see this is the displacement where earlier the this was like that, but after the displacement, this get displacement with some magnitude. So here is another example of how the earthquake is occurring. Here you can see this rectangular bed. This is the fault line, and this is the focus, and this is the fault strike of the fault line, where you can see after the when the displacement take place from here, energy get spreaded over this block, and you know what is extra, the perpendicular distance from the focus to the surface is the epicenter. And so there is two types of body wave. One is longitudinal wave, another is transverse wave. Body wave, longitudinal wave is P wave, where the direction of this wave is parallel to the direction of the motion of the wave. But the direction of the transverse wave is perpendicular to the direction of the motion of the wave. So it oscillates perpendicularly to the propagation direction of the wave, and it moves parallel to the direction of the parallel propagation of the wave. And here you can see this is steel condition, and then when this seismic energy propagate, so first P wave move, then S wave. After that, after some time, S wave start moving toward the surface. So here you can see how waves are moving and how this building get damaged and seared. So during the P wave, first compression, then expansion, compression, expansion, like the particle movement will take place in P wave. But in this, searing will take place. So this is another type of surface wave. When P and S wave move, after that surface wave, which is a very high wavelength and low frequency wave. So surface waves are two types: Rayleigh wave and love wave. And amplitude diminishes with depth, and they have a large amplitude and slower than the body wave. But they are dispersive and they are very destructive. So here you can see they are having P and SV, and means Rayleigh wave having P and SV type of nature, means elliptical type of wave are this is, and love wave are SS type of wave. Both are very destructive. And this is the type of wiggle, means this is on seismogram. Earlier people used to get this type of wiggle on analog basis, but now we have very technology based digital type of seismogram we have. So we are recording now this earthquake digitally. So first P, then S, surface waves. So we are recording this in three direction: up and down, north south, and east west. Here you can see seismographs. Earlier, people used to record earthquake like this, means analog wise they recording the earthquake. But now we have a digital seismograph. Here you can see digital seismograph, and here is the how we can locate the earthquake. So here you can see knowing the difference in the arrival time means first P wave when the earthquake occur, energy first wave is P wave. After some time S wave move. So the difference in the arrival time of the two wave, knowing their velocity, we may calculate the distance of the epicenter. Okay, this is done using the travel time curve, which show how long does it take P and S to reach the some epicentral distance. So here you can find out the epicentral distance. So by that you can locate the earthquake. And here is the locating the epicenter, means from where earthquake occur. What is the location of the earthquake? So using this phenomena, you can locate the earthquake. Means first you will calculate the epicentral distance. After calculating the epicenter, you will draw a diameter, means circle. So you need at least 3 stations to calculate the epicenter. So here is the observational seismology magnitude determination. Once you will get the travel time difference and amplitude, so you, after keeping this magnitude in between these two images and making scale same, you may find out the what is the magnitude of the earthquake. So here is the formula to get the magnitude. And now come to the means how we can define the different magnitude. Means if having different type of magnitude, so how it can means affect people, our societal people naturally. So if it is 2, so it is felt by very few. If it is 3, then felt by some people. Vibration like a passing having vehicle. But if it is 8 or 9, complete devastation, ground. So it is very dangerous. And this is the European microseismic scale, EMS 98. Okay, so where the microseismic scale is, one is not felt, second is scarcely felt, third is weak, largely observed, 5 is strong. And like that there is 12 micro, 1 to 12 micro seismic scale, and if there is 12, then it is completely devastating. Now come to if earthquake is occurring at large depth, so how it will move. So this visualization of the seismic wave in beneath the earth. This is crust, then it is mantle, then it is outer core, and it is inner core. So how wave is moving inside the earth, here is the visualization. And here is the different types of generation, means P wave, PK, SP, means different type of transition is there at different boundary. So here is the transition. Now come to the can be divided into two groups, geohydrical, geophysical. But I am going to explain you how you can use seismic refraction method to extract groundwater. So you know exploration, determination of distinctly different water bearing layer. All that you can find out using seismic refraction method. So how we can use this seismic refraction method? Here is the source. At point A, there is source where you are exploding the dynamites. So after exploding, seismic wave occur. So it penetrate, it transmit downside. It goes at different interface, and when it meets at this interface, so if velocity is increasing, means V greater than V1, then only seismic refraction occur. So after this phenomena occur, and once this it get then what will happen? This wave will start moving horizontally, means from the second layer it will start moving, and once it will get the critical angle, then it will reflect it back to the surface. So you know source waves are generally produced by exploding dynamites in a hand auger. Also you can use, if your budget is not good, then you can use hand auger backfill hole of about 1 meter depth. Sometimes method of hammering a thin plate placed over surface is also used. On the emergence of this wave refraction surface boundary and detected by suitable device called geophone. And how we can detect this seismic wave? We are using geophone on ground surface, and we are when we are in marine, so there we are using hydrophone to record this seismic wave, and there we are using air gun as a active source to generate the seismic pulse, means sound wave. And this is the diagram for geophone, and where is the different component. This is the principle of seismic diffraction method. Means first we have to calculate we have to find out the Snell's law. Means we have to prove the Snell's law. Means how Snell's law we have the earth and for this interface when we are using seismic diffraction method. So this here is the calculation. Here is the theory for Snell's law. And then this 90 means diffraction is 90. So sin theta will equal to V1 upon V2, where V1 is the velocity of first interface, V2 is the velocity of second interface. And here is the diagram where this up to here direct wave curve is there, but from here this is the curve for refracted wave. Means x6, x7, x8, x9, x10 this is the travel time difference for the refracted wave. So here you can see I am showing you parallelly. Means from here to here this is this wave arrival. From here to here this time is, and this is the t to calculate the travel time, to calculate the depth of the aquifer, and what is the depth, what is the time it is taking to depth to the aquifer. So from here you can calculate. And also, so I am going to show you how we can calculate this time determination of depth to aquifer. So this is the direct wave. Okay, TD is equal to x by V1. Means this from here to here when wave is going, this is the direct wave. So this is the direct wave, and this is the refracted wave. Refracted wave means this is let me come to back this AB, BC and CD. So this is the total time for the from A to D. So this is the AB upon B1. This from here you will calculate the TR and then TI. After getting the TI, you may calculate the depth to the formation. Means at what depth water formation is. So you can calculate out the depth to the formation and travel time difference. And crossover distance means this is a method from one side, but to cross check means to validate your method whether you are doing in right way or not, because you have when you have a limited budget, so you have to check from both sides. You have to do survey from both of the sides, means from left right and right left. So when you will merge both of the data, so you will get a confidence that what I am doing at what depth I am getting the aquifer, it is correct. So for that we do the crossover distance method. Here is this is a method for 3 bed. Earlier I was showing you 2 bed. Here is a V1, V2, V3. Okay. So for that you will get this type of travel time information. Total time is this. So like that you can do for n number of interface. I have shown you 2 bed and 3 bed, but you can add more number of bed and you can do this calculation. And here is the data, means when bed is not horizontal, bed is slow, so you will get this type of structure. So your problem will be complex. So now you have to add angle theta, alpha, to calculate the depth to the aquifer. So now I am going to give you the overview of GPR. GPR is basically ground penetrating radar, and it uses the radar signal, means radio detection and ranging. And to detect, earlier it was detected by aircraft, shift, vehicle, bird, rainstorm, and other ground object. And many diverse design and method of operation, but in common is the transmission of electromagnetic energy, usually a pulse. What energy is electromagnetic energy, and detection of small amount of energy which is reflected from the target. And what we are doing here, we are mainly recording the time delay of the reflection which contain information on the target of the range of the target. And here is the various application where we may apply GPR method. So in geology, we may interested to know different type of structure, means fold, infold, anticline, syncline, and in fault. We are interested in different types of fault. There is a fault scarp, thrust, all that we are interested. So how it works, I am going to explain you how it works. So georadar transmits a very short pulse of EM energy into material by transmitting antenna. Here is the antenna which is having transmitter and receiver together. So first you are sending the signal, means the red one is the transmitting signal, and the blue one is the receiving signal which is reflected from the target. But if the target is not there, so what you will get? You will get nothing. So you can see here, it is transmitting, but it is doing nothing, does not receiving any signal. But here is the target, that's why it is receiving the reflected signal. So here you can see the how if the antenna is moving in this particular direction, if this is the target, so how will be the signal? So here you will get this type of signal for this target. If you are moving in this direction, so this is the direction, and in vertical this is the travel time difference, and after in radar map you will get this type of picture. Here you will see the visualization, means how if the target is there and antenna is moving in this direction, so how it will be visualized. It is not showing here, it is showing in problem, but I am explaining you. This is antenna, first point, this is second point, third point, 5, 6. So this is for 6 point. First antenna is here, so signal is reaching by like that, means it is taking too much time. So signal is coming like that. And when it is near to the target, so it is slightly up, but when it is very much near, so you will get very near signal. Again it will go far, so you will get like this picture. And when the target is horizontal, so you will get a horizontal signal. So it is very rare in real time. You will never find this type of structure. Very few of the target are like this. You will find the target which is having some angle, which is having some orientation. So this is the image of the whole equipment is like this. GPR equipment, where computer, control unit, battery, RS antenna and TX antenna. And the transmitting antenna is sending the signal like this. Transmitter trigger, and this is the inputs at the fixed point here, and this is the antenna where it is having electric field in this direction. So when you are doing the survey, you have to be very careful. Means this alignment should be perpendicular to the area of target. This should not be parallel like that, with some angle tilt. It should be perpendicular to a target. Then only maximum signal will go to the target and will come back to the surface, and it will record to the receiver. So this is the radiated pulse. This is the radiated pulse which after this two combination. This is the receiving antenna. once the signal is received like that, so it will digitized. Signal will be digitized because we want this in mechanical form. Means it converts the energy from mechanical energy to electrical energy. But here we are this is EM energy only. So this is digitizing the energy, and it is coming back to the computer, and we are getting it in travel time difference. After that, we are doing the processing. So there, where we are stacking all the travel time difference, means all the data, and after stacking, we will get the continuous information. This is the electric field direction of the antenna. Here is the example. If the antenna direction is like this and this is the target, then this is the optimal detection. But if it is perpendicular, then it will be low detection, because now the electric field direction is like this. But when the target is having some orientation, then you will have some your antenna should be like this. Then only you will be detecting this target. Otherwise, it will be very difficult. When this till now I have explained you the 2D survey, but you may do 3D survey. If you means when you want to check you want to know the lateral extension of the target, the volume, you want to do some quantity work. So you have to make it grid, and then you have to do this survey in longitudinal and transverse direction. Then once you will find this target, so you have to plan like this, that your target should come in this grid. Then only you will get the volume of this target. And how you enhance the accuracy of the result. So if you are doing this survey means using only one antenna, so you will never enhance this accuracy. When you will enhance, when you will have an array of antenna, means you will have it 4 number, 5 number, or 10 numbers of antenna together, and you are moving along a target. Then only you will enhance the result. But this need too much money. When you have a good budget, then only you can do this type of survey. So but when you have, because when you are going to purchase this only will cost 60-70 lakhs. But when you are going to purchase this, so it will go by 1 crore. So this is the question you can ask further. How deep I can see, what is the minimum target I can detect, what is the accuracy achievable by GPR, what are the horizontal and vertical resolution that I can expect. So this you can do by means if you are using EM method, so it is having limitation of conductivity. When conductivity is very high, so signal will not penetrate much deeper, because the signal will get attenuated at the near surface, because where the conductivity is more, their charge ionization will take place in the rock. Due to the ionization, ions will start moving in that region only, and a signal will get attenuated, so it will not go downside. So you have to be very careful when you are using this method. And also it depends on dielectric constant. So what air is having water is having 81 dielectric constant, and dielectric constant is very for different types of soil. And the strength of the reflection means from where, if it is having it is reflecting from the interface, so reflection is mainly controlled by the contrast in the dielectric constant of the two adjacent material. If dielectric constant is, I already told you, if there is a conductivity high, so reflected signal will be very less. But if it is less, then it will be high. So low conductivity, excellent radar condition, medium conductivity, radar condition, and high conductivity, poor radar condition. So, and this to check very carefully. And our range depth decreases, electric conductivity increases, water content increases, clay content increases, scattering increases. So if all this increases, then depth increases. If it is when it will be increases if frequency decreases, receiver sensitivity increases, transmitter power increases, means frequency decreases, means frequency decreases means wavelength increases. Once wavelength will be increased, so what will happen? Signal will go downside more, because now it is having long wavelength, so it will not attenuate at near surface. But when we are going to use this high wavelength, so our resolution will be less for the near surface, also for the higher surface also. But when we are using lower wavelength, means higher frequency, so resolution will be very good. So this is the limitation when we are using this method. GPR accuracy of location, so horizontal accuracy and vertical accuracy. Horizontal accuracy will depend on how we are moving in horizontally, and how is the terrain, how is the topographical condition. Okay, all that is necessary to know. And vertical accuracy is limited by GPR is capable to measure the time of flight. Inaccuracies can be due to the time or depth conversion that requires accurate evaluation of the propagation velocity in the medium. So okay, so when you are going to check vertical accuracy, so you have to very careful. You have to calculate the propagation velocity. So propagation velocity you can calculate by the parabola. So this is the performance summary. And here is the one case study which I have performed in Tapkeshwar temple. So here is limestone as indicated by its velocity, possibly cave. Here this is the maximum signal, and other possible cavities like this. And this is the noise. And here is the erodative position, our made field. This up to this depth, unconformity is there, and there is the clay formation. And this is the parabola. Using this parabola, you can find out the propagation velocity. Now come to the magnetologic method. Magnetologic method use the passive wave to find out the electric and magnetic. It's measure the electric and magnetic field using the passive wave. Passive wave, which is coming from interaction of the solar and earth magnetic field. Another is the lightning, thunderstorm. This gives the high frequency signal, and this gives the low frequency signal. Using this high frequency and low frequency signal, we measure the 5 component of the electric and magnetic field, 2 component of the electric field and 3 component of the magnetic field. And we keep this equipment for at least 3-4 days to get the information up to 50 kilometers. So for depth, we can get the information using this method. The 5 component field setup is like this. This is the dipole to calculate the electric field, and this is the magnetometer. And here is the Maxwell equation to find out the in time domain. Here is the Faraday law, Ampere law, Gauss law, and Gauss law for magnetism. Here is the physical properties with field. You know already, there is a current density, electric field, displacement current, and electric field and magnetic field. And here is the magnetologic response. Once you will find out the this impedance, then you are going to calculate the apparent resistivity. Why it is apparent resistivity? Because it is the aggregate from number of rocks. So that's why it is apparent resistivity. And this is the phase. You may find out the phase and resistivity using the magnetologic. Here is the 2D inversion. This is the true resistivity. And this is the resistivity, means this is the 2D section. from Roorkee to Gangotri region, and this is the result after from 24-25 station data, and every station has kept at least for 3-4 days for recording. After that, this section we got. So here you can see 0-50 kilometer depth. So this is the near surface conductive body. This is the higher depth, means after 10 kilometer this conductive information we have, and this is the resistive information, and this is the accuracy, means RMS error, how much accurate the model is calculated and observed. Now come to the soil electrical conductivity resistivity method. This method we can utilize for to gauge the water saturation, fluid conductivity, porosity, permeability, presence of material, metal. Can be used for geologic feather with distinctive electrical properties, locate contaminant, plumb, salt water intrusion, stratigraphic unit, sinkhole, fracture, buried drums. So many of the for many application it can be utilized. So mode of investigation is we can do in two way. Means we can do the profiling, we can do the sounding. You already know. I think profiling we can perform to know the lateral variation. When we perform profiling to know the lateral variation, and when we perform sounding, when we have a when we want to know the vertical variation. So then we use these two type of method, and this is the application. And once you will do the setup, once you will complete the setup, means you need at least 4 electrode, 2 electrode for to record the to generate the electric current, and two electrode to get the potential difference. Okay, when the signal is returning, electric current is returning, so it is coming in the form it is recording in the form of potential difference. So here is the here is the electrode to send the electric current down all, and this is the structure of the electric current, how electric current is going downside, and this is the to position to measure the potential difference. And geometric factor, once you will do the setup and do this then this is the geometric factor to calculate the geometry of the electrode, means how the setup is, and for what type of setup we are geometric factor we are using to send the electric current downside and receiving the potential difference. Here is the issues with array configuration, penetration depth and resolution. These are very again it is having limitation, because when you are going to have to use this for short distance, means when you are using this, so you have to very careful, because resolution is you will not get resolution after 400 means 300 meter, because the signal which will go downside it will be very less, and also again it will be limited by conductivity and resistivity. If the area is very conductive, then you will not get your resolution not good, and also depth penetration will be not good. So you have to very careful when you are using this type of method. So after once you will get this type of in that area, so you have to change the method. And noise, variation of current source typically small, most uncertainty due to the voltage measurement, noise due to the induction of the cable and voltage. And this is the various method to calculate the potential difference. Here is the Venner alpha, Venner beta, Venner gamma, pole dipole, dipole, Venner submerger. But practically we are using mainly Venner and Schlumberger method, and sometimes pole. But when you are having very complex objective, so you may use different types of method. Depth of investigation is controlled by when you are using this ground resistivity is limited by depth R of R determined by ground resistivity. Already I would explain you signal attenuated by 1 upon R cube because when it is going downside, it is attract, it is reflect, it is meet different type of raw material, different type of interface and different type of structure. So signal get attenuated. So by Ohm's law, therefore, high R gives high signal V. Receiver can detect transmitter at long Tx by Rx separation in resistivity earth. Low R gives small v, so transmitter must be near the receiver in conductive earth. Can get more separation and therefore greater depth in resistive earth. But if it is conductive, so depth will be very small. So profiling, detect lateral changes. Okay, an array parameter kept constant and return depth of penetration change only with subsurface layering. Array needs to be portable. Depth of information can be obtained if the layer information is available. And sounding, sounding means when your area is depth wise. So you are doing the sounding. So here is the formula to calculate the Schlumberger array. Means when you are doing the sounding, so you may use this formula to calculate the resistivity. So this is the setup for the Schlumberger array. And here is the various resistivity for the very different types of rock. So you can see here how resistivity vary in this type of wavelength, and this is the graphite and this is the anthracite. So you can see how much resistivity is changing for this type of signal. And here is the apparent resistivity explanation of the apparent resistivity. If there is no target, though, so RO is equal to R1. But if it is having this RA is greater than RA is less than 1, so you will get the signal like this. If it is having limestone, so RA is greater than R1. And here is the 3-layer model. When practically when we are doing this electrical resistivity survey, so we are mainly concentrating on this 4 type of curve H, K, A, Q. So the where you can see these three different type of interface having 3 different resistivity, and here is the curve. So we are using mainly this type of curve for the interpretation. And here is the case study for the landslide, means how we are using this electrical resistivity in the landslide investigation. So when you are doing this type of profiling for this landslide area, so you can see here this is a conductive, and here it is slightly in between. Here it is, you can see. So you can do temporarily. So you will get this. Now the conductivity is increasing. You can see here, and it is highly resistive. So you can check. So when you are doing this type of survey seasonally, so you can find out the parameter and the causing problem, why the landslide is occurring, and what is the cause of the landslide, and what is the triggering factor. So this is the one of the method to do landslide research using this method. Now comes to gravity. You know already gravity prospecting. We measure small variation in the force of gravity from rock within the earth. Different types of rock have different density, and dense rock have gravitational attraction. So to the left is the gravimeter. Here is the gravimeter, which is measure the force of gravity in the earth. So how you can check the which rock is having more gravity and which rock is having light, means which is having low gravity. So pyrite, which is heavy rock, and sandstone is light rock because it is having huge amount of iron material, and so that's why it is very high. And this is having very silica contains light, and this is lighter, so this so higher gravity than this. And when you are in field, so this is the geology. And what is subsurface? So you use the physical model to know this subsurface. So you make one circular type of pipe, and if you are doing some physical, you are making some physical formula to calculate this type of problem. But what geophysicists do, uses the equipment to find out the gravity anomaly. So you move in this particular direction to get this target in your data. So when you will moving means you are doing at some interval, you are doing survey in some interval. So this is the calculated, and one another is the observed. So when we are meeting both the same, so you get confidence. So from here, this type of information, this is the reflection, means this is the gravity anomaly from this type of target. This is the CG5 gravimeter, this type of gravimeter you can use any type of condition, any type of weather, any type of atmospheric condition. This gravimeter works in minus 45 to plus 45 degrees centigrade temperature. So here is the gravity reduction. Geoid, you know geoid. This geoid is the equipotential surface. Ellipsoid, we make the mathematical surface, mathematical model of the Earth using the geoid. And spheroid, you already know what asteroid is. So using this method, you can calculate h and this small h. And you know ISOTACY. So we apply this gravity method to know the isostacy phenomena, means how isostacy exists in real Earth. So this is here is the plate and array theory. You already know what array supposed. So this is the array, and this is the plate. Array says that this is having equal density but different depth. But he says it is having different density, but there is having one compensation depth, and where the this ocean having low depth, means height of the bed is low than the mountain. Now come to the means till now I have shown you the land-based measurement, means we are doing this all in land-based. But in I think you know, I don't know how much you are knowing GRACE, gravity recovery and climate experiment, where you can use this is a satellite-based method where you can apply, where you can get data from space only, and this is having two satellite. This is moving coplanar with 250 kilometer separation and of 500 kilometer altitude. So this gives gravity data. And first it measure the spherical harmonic coefficient, CNS. Once you will get this, so you will find out the gravity field. After calculating the gravity field, you may calculate the equivalent water thickness, means how the equivalent water thickness variation is globally. So you can find out this. And here is the picture of geoid. This is the gravity again GL06 combination of GRACE and GOS plus gravimetry and altimetry surface data. And here is the geoid. So you can see the beauty of this GRACE, means how the picture is we are getting. So once you will get the spherical harmonic coefficient, so this is having time variable gravity field, Means this data you can get at means every 1 month. Means they provide only 1 month solution. They are moving every time, but they are giving average value of the gravity, because one day to gravity doesn't change much. So that's why it gives a solution monthly. So static mean gravity field in form of fully normalized spherical harmonics Stokes coefficient up to degree and order 120, and this data is processing by these three different centers: CSR, GFJ, JPL, and supporting data is GAG, GAB, GAC, and this is the mathematical formula to calculate the surface mass load change, means how the groundwater is changing approximately. So to calculate that, you may use this formula to get the to solve your problem. And this is the mathematical formula to know the geoid height change, means how the geoid height is changing. So you can find out using this formula, and where this is spherical harmonic normalized spherical harmonic coefficient, and here is the this is the legendary polynomial, and LMN is the degree and order, and the R is the radius. So using this, you can calculate the surface mass load change and geoid height change, and you will get solution like this. Once you will do the processing, you will get spatial smoothing lights. So you have to apply the filter to remove this type of stripes, this type of noise. So once you will do, so you have to be very careful when you are using the filter, because sometimes what will happen when you are using, you have applied too much filter, so your data will be lost. So to get the proper signal, so you have to be very careful, and you have to apply this in with some radius. It is not that you can apply to any radius you can apply. So here you can see it is applied for 1000 kilometers. So this is the best result till now. And also there is some problem with the low degree. So to exclude this, we have to remove the data only. Means low degree term we have to remove. We don't have to use, because they have having problem with the low degree. And here is the some result for Andaman Nicobar. So here you can see this low, means this is, here is the when the earthquake occur, this part has subsided and this part gets uplifted. So if it the value you can see, and here is the time series where the upliftment take place and where the subsidence take place. At the end you have already seen subsidence take place, and at the ocean upliftment take place. So this is the change. This is not quantity. This is not in quantity, but this is the change which has been shown by the gas data. And this is Japan earthquake, where the subsidence taking place at the land and upliftment taking place at the ocean. And this is the time series. And now I am going to show you the how the groundwater depletion is taking place in the ocean in the North India. You can see, means this part is depleting means temporarily. Now also it is depleting because due to the some anthropogenic activity, and time rainfall is also getting less with time. So here is the change rate, terrestrial water storage change rate from 2003 to 2012, and this is the time series for the terrestrial water storage, soil moisture, groundwater and groundwater train. So here you can see how the groundwater is depleting for this particular region, North India. Now come to the magnetic method. Magnetic method, you can use this magnetic method to get the variation in the magnetic field of the earth. Magnetic field of the sedimentary rock is usually much smaller than igneous and metamorphic rock, because sedimentary rock having very less iron content than igneous and metamorphic rock. So let us measure it's measure the thickness of the sedimentary section of the earth crust. So using this we can measure how much the thickness of the sedimentary crust is, because it directly distinguishes the sedimentary section by the igneous or metamorphic rock. So in instrument is to left is a magnetometer, which lets us measure the magnetic field of the earth, and where when during the measuring when during the measurement we have to keep the direction in the north pole. So here is the magnetometer. So this is the magnetite, this is the sandstone. So here you can see the deflection. It is not deflecting. So now come to the how we can integrate this all the method in various application. So one of the method is I already explained you empty method, where you can use this method to get the subsurface information. So when you have the picture like this, so you can add this picture with this image, so you will get this is the HFT. So here you can see this point, it is very conductive, and also this is the point where much of the earthquake is occurring. So and this is the time series value, this is the vertical displacement, and this is the grace data, and this is the earthquake. So using this all this method and this, you can find out the cause of the earthquake, what is the material inside the earth which is where the energy is accumulating too much. So all that you can know using this method. And again when this is the seasonal I am doing this project here right now. So this is the seasonal where I am doing seasonal variation of seismicity and geotectonic strain in the Himalaya induced by surface hydrology. So what is happening? This due when the seasonally means when the groundwater table is increasing in Ganga river. So due to the load of this water, this Indian plate pushing behind means moving towards south. So what is happening? This HF, MST, NMD, NMCT all moving towards south. So but when the water table is going down, again it is moving toward north. So what is happening? When it is going south, no earthquake is coming. So you will see on data. So in summer and in monsoon time, less earthquake come than in this winter time. In winter time, most of the earthquake coming due to when the plate is moving toward northward, so compression take place. But when it is moving south direction, so expansion takes place. So that's why this is the main problem of where the earthquake is occurring in the Himalayan region. One of the reason, and right now I am doing this project here, and this is the another diagram. This is the fault plane solution. So using this fault plane solution, you will get what type of fault is there, means normal fault, thrust fault, strike slip fault. So to know that, you may do this type of you may apply this type of method to get the fault plane solution. So this is strike slip, means when you will get this type of structure in this circle, so you will get strike slip, and this is either normal fault or thrust fault. Again this is strike slip, again this is strike slip, again this is either normal or strike fault. So this type of after knowing all this, you move to your different step, means how you can going to solve this type of problem. And here is the vector value, means velocity of GPS station with respect to ITRF 2000. So here is the velocity, means how the plate is moving and what is the magnitude to the particular points means how, what is the rate and what is the value, means by which value it is moving in which direction. So you all calculate by GPS campaign mode GPS equipment, and here is the MST, MBT, and this is the MCT. So here is the distribution of the velocity, and here is the dilatation strain. After getting this velocity, you may calculate the dilatation strain using all this data, and also maximum ACR strain you can calculate. And this is the compression and expansion, where the compression is taking place and where the expansion is taking place. All that you can calculate with the GPS station data. So thank you so much.